All right, class. So today when we're working on our posters, I'm sure there's going to be a group or two that might finish their posters a little bit ahead of schedule. And if that happens, that's okay. Eventually, I'm going to need you to kind of stop and look at other people's posters and make some comments and observations. But in the meantime, I don't necessarily want you just sitting around doing nothing. So I will let you get a head start on this robot lab. The robot lab is going to help us practice the actual coding of taking a superclass and creating subclasses from that. So the goal of this lab is to reuse this code as much code as possible, and then not to actually change the code in the superclass to try and affect the functionality of later classes. That's not something you'd ever really want to do because the superclass is supposed to function a certain way, and you wouldn't want to modify that just for one particular class. To start the lab, what you'll want to do is you'll want to download this RobotLab zip file. Don't unzip it, just download it, and then also download the RobotLab PDF. The RobotLab PDF is the description of the lab, which I have printed for you, so hopefully earlier I got that to you, but if not, it's there for you. The other thing is the zip file. It has all of the Java files that you currently need. You'll have to add to it, but it actually has everything that you need. So actually, after you download the RobotLab zip, the next thing you should do is go to Eclipse. While in Eclipse, I don't want you to make a new project. I want you to go to File, Import, Existing Projects into Workspace. Next, select Archive File, Browse, find where you downloaded that zip file to, open. When that happens, Eclipse should automatically unzip it for you and find that robot lab, and then you can hit Finish. When that happens, you should get a robot lab in your project files. And if you look in the source folder, you should have 3 different classes. You have a client class, which is the code that interacts with your objects. You have a drawing panel class. Please don't mess with that. That drawing panel class is what defines the drawing panel that's going to pop up and give you a visual image of your code and kind of show you what your code is doing. And then you have a robot class, and the robot class is our super class. You won't change any of the code that's in here, but you will need to add a couple of methods. So for example, I wrote a move right method. I need you to write a move left method. I wrote a move down. I need you to write a move up. So when you are testing your code, I already have some of it available to test, but as you go, you'll uncomment different parts of this. Right now, the only code you can have uncommented is the robot class because I've provided you with most of that. When you hit run on the client, you will get a graphic panel, and the graphic panel, this dot is what I'm calling the robot. And so if you compare what just happened is the robot moved right and down, and that's these first 2 methods that have been called. So move left and move up nothing happened because these haven't been written yet. Once you write them, it should move left and up. Then eventually in the project, you'll write a rectangle robot class, and you can uncomment this and it'll draw a rectangle. The square robot class will draw a square. The diagonal robot will draw essentially a diamond because you're going to move in 4 diagonal directions here. But the purpose of the diagonal robot is just to move diagonally once. I did the 4 of them to make sure it works in all directions. And then the last one is a Roomba robot. And the Roomba robot essentially looks like a screensaver where it'll just kind of bounce off all of the edges. One really important thing with this drawing panel that I need you to understand, in math, 0, 0 is down here at the bottom left. That is not 0, 0 in Java. 0, 0 in Java is the top left. So while moving right will increase the x coordinate like we're used to, moving down will increase the y coordinate. That's backwards from math. In math, going up is an increase in the y coordinate. In Java, in this drawing panel, it's down that's the increase. One other thing to notice, just for your sake, is that when I created this drawing panel in the client code, it's 400 wide and by 300 tall. So that's going to be important later when you get to that Roomba class, and you're going to want it to collide off the edges. we're going to need to know the size of our drawing panel. Let's see here. So just to kind of give you an idea of what a finished product will look like when you're done, I'm going to close this. So a finished product, you will have 7 different classes. The drawing panel and the client really just didn't get untouched, other than the fact that the client, you probably uncommented out all the stuff. You are going to have to add a diagonal robot class, a rectangle robot class, a Roomba class, and a square robot class. Those are the classes that are going to end up extending other classes and inheriting from them. Again, the purpose of this lab is to reuse as much code as possible. So you're not trying to rewrite things that have already been written. You're trying to just write the new extra features for those additional classes. So if I uncommented out everything and I hit run in my client, this is what you should expect to see. So this is what a finished product will look like. I'll start with my just first move. Oops, wrong client class. Sorry. Client class. And I will hit run. So I will get the move right, down, left, and all of those, and I'll get my rectangle. This is my square. So that's now my square. I'll get a diagonal now, and it'll have all 4 diagonal directions. And then I'll get my Roomba. And the Roomba, you'll see, it's going to act as if every time it hits an edge, it collides. One common mistake with this Roomba class is that people don't take into account the size of the dot, and it will disappear out of one of these sides before it collides. And so that's something that you may have to adjust in your code, that to get a perfect score, it would have to look as if it's colliding off the wall, not disappearing and then colliding. So those are some of the things to work on. Remember, this is a lab, so you're allowed to collaborate and work with your peers. That's what's expected. It's not just allowed to. Someone should step up, even though I don't have the forms ready yet. Someone should step up and be a leader, because that team leader, it's really important. You don't have to have the ideas to be the team leader. You just have to keep all the ideas out in the open and make sure that everyone's together and on the same page. So that's it. Eventually, we'll all be on this lab together, and I'll be able to answer a few more questions. But in the meantime, I'll really just let you kind of work on this while teams finish their posters, and then we'll get going as a class.